So in the last video, we learned how to balance a half reaction if it was an acidic solution. In this video, we're going to talk about how to balance a half reaction if it's a basic solution. Now it starts out exactly the way it was before. We need to determine who's being oxidized, who's being reduced, and how it's changing. So if I look, I've got three different things here. I've got Ag, I've got Cn, which is a polyatomic ion of carbon and nitrogen with a -1 charge, and I've got O. Well, if I look at the other side, I've got Ag and Cn partnered up now. Because the C and the N are still together, there's still a polyatomic ion. The charge hasn't changed, the oxidation numbers haven't changed. So this one is basically a spectator ion in terms of redox potential. Its charges aren't actually going to change. Silver, on the other hand, is going to start out as a solid, so it has an oxidation number of 0. Over here, it's an ion. I've got two CNs, which each have a -1 charge. The overall charge is a -1, so silver has to be a +1. So Ag is going from a 0 to a +1. So Ag is going to form AgCN2 negative. Now here's the problem. It's not just Ag forming this. It needs to react with Cn to form this. Now remember, if I had an acidic solution, I'm starting out the same way. I balance everything except for H's and O's first. So in this case, I've got 1 Cn, I've got 2 Cn's, so I'm going to multiply this by 2. I went from a 0 to a +1, so I lost 1 electron. Okay? Now, what I'm going to have to do with the O is a little bit trickier. Right now, my O is starting out as a gas. It's an element with elemental form. It has an oxidation number of 0. Well, it's got to turn into something. That something isn't shown over here, so I'm going to have to figure out what's happening to it. Now, in an acidic solution, we said we balance our oxygens by adding water. And because I've got 2 oxygens here, I need to have 2 oxygens there. Then we said we balance the H's with H pluses. Because I had 4 H's here, I have to have 4 H's there. That's good. Now I need to figure out what's happening with my electrons. My oxygens, each oxygen is in O2. Each oxygen is an element. Each oxygen is 0. It's becoming H2O with a -2. So 1 oxygen goes from 0 to -2. It's going to gain 2 electrons. The second oxygen is going to go from 0 to -2. It's also gaining 2 electrons. So I'm going to have to gain a total of 4 electrons because each O gains 2. Now, I need to make sure my electrons are equal. Since they're not, I need to multiply this entire reaction by 4. So I'm going to have 4 Ags. I'm going to have 8 Cns. I'm going to have 4 AgCN2s and 4 electrons. Okay? Now, anything that's the same on the left and the right, I'm going to cancel out. I have 4 electrons here, 4 electrons here. So when it's done, I've got 4 AGs plus 8 CN negatives plus 4 H pluses plus O2 is going to form 4 AgCN2 and 2 H2Os. Now, if this were an acidic solution, I'd be done because I have these H pluses floating around. But it's not acidic. It's basic. So what I'm going to do is I need to add base. Bases are OHs. Now I need to add enough OHs to cancel out my H pluses. So since I have 4 H pluses, I need 4 OH minuses. Now, because this is an equation, anything I do to the left, I have to do to the right. So since I have 4 OHs on this side, I also need 4 OHs on that side. Now on the left side, my H's and my OHs are going to come together to make 4 waters. Now, just like before, what I'm going to need to do is I need to cancel out anything that looks the same on the left and the right. And in this case, the only thing that I've changed is my water. I've got 4 waters on this side, 2 waters on this side. So all of my waters go away over here. 2 of my waters go away over here. So when it's completely balanced, I'm going to have 4 AGs plus 8 CN negatives plus 2 waters and oxygen. I'm going to form 4 AgCN2, and it is a basic solution, so I'm going to have these 4 OH negatives. Okay? So it starts out exactly the same way as balancing an acid-base reaction. Everything to here is exactly like what we would do if we had an acidic half reaction. Once we get everything balanced and we have our acidic solution, we get rid of our H pluses by adding the same amount of OH minuses. Those turn into water. We do it to both sides. Then we need to simplify the waters so that I have the lowest whole number ratios. Okay? Otherwise it looks the exact same way. So take a second to solve the example that's given to you in the video. Make sure that you start out solving it as if it's acidic, and then cancel out your H pluses. So the nice thing about redox reactions is we can use them to make something called a galvanic cell. Now, what we're going to be doing is we're actually going to separate our 2 half reactions. So we're going to have one side that's being oxidized and one side that's being reduced. Now we're going to connect them with a wire. What's going to happen is as something's being oxidized, the electrons are leaving, they're moving towards the thing that's being reduced, and the electron flow is going to actually produce electric current. I can make electricity with these reactions. Now the way that this is shown below, let's say this is being oxidized, my electrons are going to start moving over here. Now the problem is as my electrons move, I've got this negative charge, and once this side becomes more negative, the reaction stops. It's really hard to get something negative more negative. So the way it's set up here, I'm not going to make very much electricity. So what I'm going to do is I'm going to either add a salt bridge, that's what's pictured here, or porous disc. What's going to happen is I'm going to have ions that are able to flow, but I'm not going to mix my solutions. And I'm going to talk about what that means in a second. Okay? So the whole point of a galvanic cell, pages are sticking, sorry. There we go. The whole point of a galvanic cell is I'm taking chemical energy and I'm turning it into electrical energy. So I'm making a simple battery, okay? My battery has two parts. It has an anode. My anode is being oxidized. So it's going to lose electrons. My cathode is going to be reduced. It is going to gain electrons. Both things have to happen together, okay? So let's take a look. Whoops, wrong way. Right way. Let's take a look at our galvanic cell here. So in my galvanic cell, I'm going to have a metal. So this is my solid metal. Let's say my solid metal is zinc. It's going to be put in a solution. The solution is going to have this ion. So I'm going to have zinc 2+, and then something else because I'm going to dissolve the salt. So let's say it's SO4 2-. I don't really care about this second ion. All I really care is that I've got a metal and it's salt. On this side, I have another metal. So let's say that I have copper. It's also floating in a solution or suspended in a solution. And this solution has its salt. Again, it doesn't matter what the other ion is. I only care that I have the metal and its ion. Okay? Now, the way that I determine how the electrons move is by looking at the activity series. So we talked about this before. Here's our activity series. We said that if an element is higher, it is more easily oxidized. It loses electrons. So I've got zinc, which is here. I've got copper, which is here. Because zinc is higher, it wants to lose electrons. So what happens is my zinc metal is going to lose electrons. Those electrons flow this way. Because zinc is being oxidized, it's losing electrons. This side is my anode. Now the electrons are flowing to the copper because copper is gaining electrons. This is my cathode. Now a little way to remember it. Red cat. The side that's reduced is my cathode. So just pretend you have a red cat running around. Now again, my electrons are moving this way. If I don't have a salt bridge, my reaction's going to stop as soon as this side becomes more negative. So what the salt bridge is it's a hollow tube. I fill it up with solution before I flip it. That solution is going to have some sort of ion floating around. It's going to have a positive ion that's going to move this way to cancel out the negative electrons. I'm going to have a negative ion in there that's going to move this way to cancel out the positive charge that's building up here. If I don't have a way to move ions, this side becomes more negative, this side becomes more positive, and electrons stop moving. Okay? So the side that loses electrons is our anode, the side that gains electrons is our cathode, and I determine which side loses and which side gains from my activity series. Okay? In the next video, we're going to actually talk about how we calculate cell potential. All you need to know for now is that as my electrons move, it's going to create electricity that I measure in volts. Okay? A volt is a joule. We've talked about that before. Per coulomb. We'll talk about what that means later. And what I'm going to do is I'm going to actually measure it with a voltmeter. So I'll put a little device between my solutions that tells me basically how many electrons are moving and how much electricity I'm conducting or creating. And we'll talk about that next section. Okay?